we did logistic regression last time. Today we're going to do linear regression, and we're going to do two types or two exercises of linear regression. Like I had, like we did last class as well. I want you to um, do the exercise after my explanation. So probably it will take me 1 hour to explain it, and then you will have the next hour to do it by yourself and ask questions. So don't do it with me, along with me, because then you will lose track and you will miss a few steps. So listen carefully, because I will be explaining you few concepts as well in the middle. And so listen to me carefully, and then after that you can continue or do it by yourself. Okay, so you, like the previous exercise, you will download this folder. The IPYNB file you will upload on your Google Drive, and this is the data set that you will use. So these are the two things that you need for any predictive model. Make sure that you upload this IPYNB file on your Google Drive. I have this saved on my computer, so I won't download, but you will be downloading it for sure. Okay, so I will start with house price prediction. Before I actually start, give me 1 second. Before I start with the code and the exercise, let's first look at the steps. I have the steps in the mind map. So this is very similar to logistic regression, same steps, but the only difference is that it does not have the confusion matrix, because confusion matrix, if you remember, we have to find true positive, true negative, false positive, false negative, and it's dependent on zeros and ones. So your your dependent variable, your y, is zeros and ones. That's when confusion matrix works well, because you can predict the zeros and ones. But in this case, linear regression, the y is not categorical. In logistic regression, the y is categorical. In linear regression, we're actually predicting numbers. So we stop. So if you remember the logistic regression code, we have training the data set. After training, we have predicting, and then we have testing. So after predicting, everything after predicting is not there in linear regression. So we don't have testing. We don't have confusion matrix. You can do the testing part, but there is no point of it. Okay, so the prediction starts, you can start the prediction right after the training step. So, like every predictive model, you will have to find what the problem is. So the first linear regression that we're doing, we're trying to predict the price of the house, and we're trying to predict it using area. So if you look at the data set, you will see that in the data set there are two columns. We have the price and we have area. So this area will be our x, and this price will be our y. So we are predicting price based on area. So area will be our independent variable, price will be our dependent variable. So that's our x. Sorry, our y. So price is our y. Okay. That's our first step. Our second step is getting the data set. So I have already given you data set, and I have told you x is area and y is price. Then, same like the previous logistic regression, you are going to load and summarize the data. So you're loading the data with pandas. You know the code. It's pd.read underscore CSV. You're doing that with the loading data set file, the code. Then you're doing summarizing the data, and you're doing it with, again, dataset.shape and dataset.head. Question: what does dataset.shape tell you?
Number of rows and columns.
Exactly. So it tells you how many rows and columns your dataset has. What is dataset.head?
First five
This
rows.
one, the first part.
Yeah, the
Exactly.
headings of the data.
The first 5 rows. So in your dataset.head will tell you the first 5 rows of your dataset. If you put, instead of 5, if you put 10, it will tell you the first 10 rows of your data set. If you want to find the last 5 rows of your data set, it will be dataset.tail, and then you will have 5. If you want last 10 rows of your data set, you will have dataset.tail, and then in the bracket you will have 10. After that, this step was not there in our logistic regression. After that, we will visualize the data set. So by visualization, I mean we will create a chart, and in that chart, we will plot X and we will plot Y. And then we will see how that chart looks. We'll make our analysis by looking at the chart, and that's what you're going to do for your predictive model as well. So once you create a chart, a visualization, you need to explain what you see. So if you see a linear relationship, you will say there is a linear relationship. If the graph is going upwards, you will say this is a positive relationship. Graph is going downwards, you will say this is a negative relationship. You will talk about the outliers. You will talk about what are the values that, or places where there are too many data points. So what do you see in your chart? You need to explain. Okay. Then is the next step where you're telling Python that this is my X and this is my Y. So your machine does not know what is your X and your Y. So here you're going to tell your data set that. Now in this, they're using dataset.drop. This means that it is saying that drop the price column. So in your data set, you have area and price. You can directly tell the machine that dataset.area is my X. But they wanted to complicate. So what they are doing is they're doing dataset.drop. So they are dropping their price. This you can make it easier by just doing, so if you look at this dataset dot price is your Y, you can use the same code here as well. You can do dataset dot area. You don't have to do this drop price and it's a column. So this is a longer method. So instead of this, you can do dataset dot area. And then another way, which we did last class, you can do dataset bracket bracket in semicolons. You will have area, close the bracket. Okay, so that's another way that we did in last class. Now, then you will put a code for the algorithm that you're going to apply. So that will be linear regression. In here, and you know what linear regression is. We're inserting a trend line in so there are points, and in between these points, we're inserting a trend line, and then we're looking what is the difference between the actual point and whatever we are predicting. Manually speaking, or if machine learning or Excel was not there, you would have done something like this. You would have done some manual calculations, and that's the formula for. So the formula is y is equal to mx plus c, and this m you would find through this formula. Based on this m, you will find c then, and then you would find the equation, and you would do a manual process. This manual process I have written here. You can open each one if you want to know the manual process. You can find each value and you can find the equation of the line. But we don't need this because now we have automated systems. So we will use machine learning to get the equation of the line, the M, and the C. We will get everything through machine learning. Okay, so we'll get the intercept, we'll get the coefficient through machine learning. Okay, then after that, we have our training, you know that. And then, so see, after this, there is right away prediction. We're not doing testing, we're not doing confusion matrix. This is a very simpler version of regression. Logistic regression is a more complicated version, and there is more, you can say, and why logistic regression has confusion matrix? Because if you remember, in logistic regression, we had categorical variables. And in supervised learning, we have something called classification. So when you want to classify zeros and ones, that's why we're using logistic regression. That's why we're using confusion matrix. And it's a more better way of a prediction. Linear regression is a simpler version of machine learning and regression. Okay, so any questions regarding the process? Do you have any questions? Hmm, no questions?
Mrs. Anna, you can get back to the when the plot is showing us the graphics.
Sure, 1 second. That one?
That one, yeah. But the previous one, you say that the model is gonna give you this kind of plot or the other one?
No, it will not give you this kind of plot. It will give you, so you're not finding a plot for all the variables. You're actually finding plot between 1x and 1y. I will show you what the plot will give you. Okay, it won't be a linear relationship. It will show you a different, it will show you the relationship. So in this, we're having relationship with this one will show you when you have 1x and 1y. In this case, we have 1x and 1y. It will show this graph. But for example, if you have multiple variables, you will not have such kind of graph. You will have a different graph. So it really depends on the question. But in this question, you will get such kind of graph. I will show it to you. Okay, so now, any other questions? Let me open my Google Drive. Okay, I will, same procedure. I will open my collab notebooks. In my, let me see if I have another file. Yes, I have another file uploaded here. And another file uploaded here. File here. Okay, so now I will upload that house prediction file. And where is it? So the IPYNB file. So this is the IPYNB file. I will upload this file. So you can see type is IPYNB. I will upload this file on the Google Drive. And I will open this. Now, in this, we start with importing pandas because we want the file to read the CSV file. We want Python to read the CSV file, so we need to import pandas. Then, like you remember, when we are importing any machine learning algorithm, we use the library called sklearn. So we have sklearn here. Now we have something called import matplot library.pyplot. This is the library for plotting graphs. So we need to import this library and we will name it as PLT. So whenever we write a code, we don't have to write this entire library name. We will just put PLT in our code. So as you can see here, we're doing plot, X label, plot, Y label. So we're just going to put that. Okay. The next, so I will run this. Running this and probably the code is initializing. Sorry, any questions?
So in we can use any number of x variables and have to use only one y variable, right?
Yes, your y is always 1 because your dependent variable you will so what is y? It is the so it's the value that you want to see is being affected. So there'll be only
Okay.
one that is affected. And what is it affected with? There can be many. variables that can affect y, or there can be only one that can affect y. So in this code, we're only looking at one x. What is this x effect on y? In multiple, which is the next one, we will have three x's and we'll see how it's affecting y. Okay?
Okay.
All right. Now, then we're loading the data set. So we need to upload the Excel file. You will choose files, and from that, you will put this data set. Now, make sure this CSV file name is similar to this CSV file name. You're loading the data set here. So you're doing pandas, read the CSV file. You will run this code. The next one, you're doing print dataset.shape. The dataset.shape is here. You're saying what is the shape of the dataset and what is the first five values of the dataset. Uh, so in this, then why you're putting print here? Because if I remove print, it will just run and it will not so it will not print. So you can see it's not printing the rows and the columns. That's why we have to put print here. So if we put print here, it will print those values. Okay, so the values will be printed. Then we have visualization of data. So here, as you know from your data set, we have area and we have price. This is our two columns. Area is our X, price is our Y. So we will say PLT, that means plot X label, and the label is area, and then plot Y label price. This area and price is not this word. Why? Because I'm just telling the plot right now that plot this label and plot this label. So plot it as capital A, area, and plot Y label as price. Here only labeling is happening. It's just a label. The plotting is happening through this code. So now you're telling the the system or the machine, plot a scatter plot. What are you plotting? So you're plotting it from the data set. This should be area. So you're plotting dataset dot area and you're plotting dataset dot price. So these are the values. Now you see, this is the column names. This is just labeling those names. So we're just labeling these columns here. Then we are saying when you plot, those dots that are there in your graph should be red and those dots should be in star shape. Okay, now let's play this and run this, and you can see this is our area and this is our price. So this is the labeling. So see, it's similar to the labels. So we're just labeling here. Here we're creating the scatter plot. This is our red. These are our dots. Now, what do you understand, or how would you explain this graph? You would say that so one of the outliers, we had extreme area where we had about 250,000 of area square feet, but the price is around 400,000. Majority of the prices are between 0 and 50,000, and the square feet is 500. Wait, my bad. Majority of the prices are between 0 and 500,000, and these houses have an area of 0 to 50,000 square feet. Then the highest price is for two of the houses, and these two houses have more than 700,000 price, but the area for these houses are um, maybe 20,000 square feet. So this explanation, how I have explained it, when you're doing your predictive model and you make your visualization, you need to explain the visualization. So majority of you, what you're doing is, so this happened in your predictive model. To be honest, sorry, your analytical reports. To be honest, very, very, very bad reports. So what happened in that is You are telling me how you're making the steps. You are um, you are telling me, oh, this is the step that I have, this is the step that I have, and this is what I did. I do not want steps. I don't want you to tell me that this is how I got this number. I want you to analyze, explain that number. Majority of you got 70s, 60s. The reason behind this is that you did not explain those values. Okay. One question, did you all receive your grades? I don't think so, right?
No, not yet.
No.
Oh,
Not yet,
okay.
ma'am.
Yeah, probably I forgot to enter your grades because I remember I never graded Nidhi or Srilata or Agam. My bad. I will upload your grades today. I completely forgot. I uploaded the grades for the rest two sections. I forgot your section. I will upload your grades after this class, okay? Uh, so you need to explain the graphs properly, okay? For your predictive model, make sure that you are explaining those graphs, okay? Then after visualization step, we have segregation. So like I said, is data set dot drop is no point of this code. It is okay, you can do it, but it's a complicated code. So instead of doing this, I will do something else. I will do data set dot area. Okay, and then I will do data set dot price. Instead of this, you can do another one. You can do data set bracket, put apostrophe and put area. That's another one. And then data set bracket, apostrophe and price. So what happens is usually if you're doing pandas or if there is a code of pandas that is coming in the future, okay, that's when you should use a table format code. But if, for example, you have a numpy that is coming in the code later, that means you have the words NP, then I would suggest stick with this code, because then you won't have an error. But right now in this particular code, you do not have numpy or pandas. So you can use anything. You can use this code or that code. So you don't have any NP or PD in the future codes. So you can use any code to bring your X and Y. Okay. Now our segregation is done. Here we will train the data set using linear regression. So you will take the model, you will put it as linear regression. Then you will say that this model should bring X and Y. Our X and Y are defined here. We'll run that. Okay, it's because of the array. That's why it's not reading it. Let's try this. Now it works. So you can see that code will not work because it was not in a table format. So that's why I converted it into table format and now it works properly. Okay, so make sure that if it doesn't work, you try a different code. Okay, then I will run. Now this one is where, so if you remember the mind map, I said after you train your model is trained, and after training your model, you do some prediction. So here you're doing the prediction part. You're saying that if my X is this, what that, and my X is actually the area, based on my area, predict my price. Okay, so you're saying based on my predicted model result, that means based on my area, predict based on my model. Okay, so this is our model. So predict based on our model, and where are you going to predict it from? You're going to use that area number and you're going to predict the value. So if I put 40,000 here, this is my price. Now, if I change this to 30,000, this means my area is 30,000. 221835 will be my price. So if you go to your graph, 2281 is somewhere here, and 2281 is somewhere here, and your area is somewhere here, right? So this prediction is correct
Sorry,
because it's falling in the
sorry,
same
ma'am.
area.
Where are we seeing the price, ma'am? I didn't get that.
The price here. So once you run the code, your price will come here.
Oh, okay, okay,
Okay, it will come in the
okay,
output area. So here
okay.
we're putting random exits to find our future prices. So what is happening? This is our past data that we had. So this is our past data, X and Y. Based on your past data, you're getting values for any future values or any values that are not seen. So these are values that might not be there in your past data or some new values. So let's say 37500 is your area. Now from your area, you want the machine to predict your price. So it is predicting price. So this is the price. Okay. And
Okay,
let's say I will put 7500. It will give me a new price. Okay. Let's say if I increase the area to 100, 675, it will give me a bigger price. Based on this, at the top, when you look at your graph, you will see that when you look at this graph, your prediction is right because it will 100, 375 will fall somewhere here. Okay, and that means your value will be somewhere between 300 to 400, right? So it is coming as 300 something. So your prediction is right. So based on, you can see, based on those values or that chart or based on those previous values, it's making judgment about the future. Okay. Now you want to check if your model is correct or not. Now I wouldn't say you're checking the model is correct or not, but it's like this is what you would have done manually, meaning you would have find the coefficient and the intercept, you would have find the coefficient and the constant. This is what you're doing through codes. So in this, what you're doing is, so let's say this is our equation, y is equal to mx plus b. M is our coefficient, b is our intercept. Now we're asking Python, what is the coefficient of the model? Do I know the model? Yes, I have defined the model here. My model is linear regression. So what is the coefficient of the linear regression? We print that m. So we print that coefficient. So our coefficient here, that means our coefficient for x is 2.0999. Then we ask the model, what is our intercept? What is our constant for our model, for our linear regression model? We will run this. And this is our constant. This means that if the area is 0, that means if we have 0 area, then our price would be this, 158836. Now what you're doing in the next one is you're putting this m and b in the equation. Okay, so I will put m and b. I'll put the formula here. Y is equal to m times x plus b. Now based on this, you know you have your m from here, you have your b from here, and your x is coming from here. Okay, now when you run this answer 106675 will be similar to this. Sorry. 1 second, why it's not printing? It should print. Yes, so this answer 370,250 should be similar to this 370,250. It is similar, that means your model is working fine, because sometimes what happens is you might make an error here in the code. Maybe this might not be equal, and this might not be equal. So because of that, it's better if you check. So if I change this x to, let's say, 27500, Okay, and if I run this again, it will give me a new X 216585 and 216585. This is the code for linear regression. I will show you another linear regression, but before that, is this code clear?
Very clear.
Yes. Yeah, okay. So this is an easier version of logistic regression. Okay, so it's much easier than logistic regression. Now, multiple is the same thing. But before we continue, I want to give you an idea about how will you do your predictive model coding. Okay, so let's say I create a new file. What do you have to do in your predictive model is just copy paste your codes. That's it. That's the only thing that you will do. The part where you will have to work on is the analysis part, the writing part. The code is already given to you by me. Okay, so let's say I name this as predictive model assignment. Predictive model assignment. Okay, let me increase this. And what I do is I will copy paste this code. So first I need to import the libraries. I will import the libraries. Okay, then I will insert another code. After importing the libraries, I need to import the file. Okay, so I will copy paste this here. Control C, Control V. Okay, then the next step is I will so if you want to run this, I can run this. So I'm giving you an idea, so you don't ask me, oh, how will we use this code? You will just copy paste this code, nothing else. Okay, you don't have to create a code from scratch. The codes are given to you, just copy paste it for your assignment. Okay. Second, it's running now. Yes, now it's asking me for the file. I will upload the predictive model file. So that is this one, dataset TM. So I will upload that. Now what is my next step? My next step is loading the dataset. Copy paste, put it in the new code. Now here in dataset.csv, I will copy paste this. Okay, I will play this. That's done. Now I will enter the next code. So after reading the file, what is the next step? Summarizing the file. Next, this one, copy paste, run this, and you will have this. This one you will explain. Okay, you will need to explain these values. You will say that this data set, this is what you will do in your Word document. This data set has 1460 rows, 81 columns, and the first, maybe if you see something, you can say that there are non-available values for some of the rows. Okay, you can do that, but it's better if you I would suggest that for your data set, since your data set for your predictive model is too big and there are some non-available values, I will give you a code for removing non-available values, but in this data set, only select the variables that you are going to use. So for example, this is my sales price. I will keep this as my Y. Okay. And then I need to predict my sales price based on my X's. So I will choose my X's here. Try to choose numeric values. It will be easier. If you want to choose the word values, you would have to convert it to zeros and ones. So you would have to convert this attached, detached, built-in. You would have to convert this to numbers. Okay. So use the numeric values. Okay. Any questions?
Ma'am,
Yeah.
like you said, if you want alphabetical things, then we have to change it to zeros and ones. So if there are three things like you
One,
showed,
two, three.
yeah, one, two, three. So how zero and one will work? Like
No,
1,
then you
0,
choose
2.
1, 2, 3. You have to convert it to numbers.
Okay,
That's the
that's
question. That's the point.
okay. Okay. Yeah.
Okay, if there are 10 numbers, you will convert it to 10. If there are 10 different words, you will convert from 1 to 10.
Okay. Okay. Thank
Okay,
you. Yeah.
no problem.
If we have to load the data set, do we have to load all of it or just the number of columns that we are using?
You can just load the number of columns. So
Okay.
delete the ones that you don't want and then load it. It will be better. But I will show you a code for NA values. You can remove those NA values through that. So in our next code, we're going to use a code to remove NA values. Okay. Okay. Now
NA,
let's do the, yes.
does NA values remove the whole set of rows or just the values in that column?
No, just NA values. It does not remove entire rows. It will
So,
select the rows. So when we do data set dot or we do data set bracket and we do area, price, age. So it will select those columns, but it will not remove the remaining. It will still be there.
so if some of the values, for example, if sales has some NA values, but area doesn't have any NA values, so it will remove the NA values from the sales. So the data would not be.
No, no. In the next in the next code, you will understand that. So
Okay.
there it is showing what the question that you are asking.
Okay.
It will show you. Just give me a second. Okay, now the next file, we're going to upload a different. So now what we're doing in the next one is, in this one, you had only one X. In this linear regression, you will have 3X's and 1Y. And we are predicting exam marks. Okay, so we're going to exam mark and I'm uploading the Python file here. Okay, the Python file is uploaded. Let me also open this file. So this is our Python file for exam marks. I will do the same thing. Now in this, I will import pandas. I will import sklearn. But in this, you see there is no math. There's no plotting like the previous code. So I can copy, if you don't have this code in the code, you can copy paste this. So you can copy paste this in your import libraries. Okay, and then I will run this. One second. Let me show you the data set for the exam mark. So if you look at the data set for the exam mark, you will see that we have marks. This is our Y. This is what we're predicting. And these three, hours, age, and internet, these three are our X's. So we're predicting marks based on these three things. Now in this, you can see there is a non-available value or a missing value. So I will explain you a code for that. Okay. Second, let's go back to the code. Now when I run this, and I will choose that file from exam prediction, data, make sure this data CSV and this data CSV is the same. So I will run the pandas code. I will do the summarization. Now you can see in this you have 201 rows, 4 columns. And when you look at the first 5 values, you see a not available value. This will be part of your analysis as well. If there are non-available values, you will say that in the first 5 rows, when I did the summarization, I saw a not available value. Okay, so you would do that. Now, before I reach this part, before I reach finding and removing NA values, let me add another code to this and look at some visualizations. Okay, so let me add a code to that column. So I'm adding a code and I can type the code. I know the code, but since if you don't know the code, copy paste. So I will copy paste this and I will do this. And let's say you want to find the relationship between, let me see, want to find the relationship between age and marks. Okay, so in this what I will do is I will name it as age. I will name it as marks. And then here, this should be exactly like how it's named in the Excel sheet. In the Excel sheet is named as age and small internet. So it is not capital. Sorry, small marks. Okay. You want to change the color, you can change the color. Okay. Now run this, you will get the graph. Okay. So you can see that different ages have different marks. You can see that once the age becomes 20, you have higher marks. Age is 17, you have higher marks. 16 and 19 has lower marks. So that's the idea for it. Now let's say if I want to change the this to hours, and let's change this to hours. Okay, you will see that there is a positive relationship between hours and marks. But there is one outlier, and that outlier is here, where this person is maybe studying for like 4.2 hours and getting marks of about 80 above. So this explanation you need to give in your predictive model. Okay, now next step is our finding and removing NA values. All right. Now this might not be there in your in your Python file on your course page. I put this from other codes that I have. Okay. So if you don't see it, I'm adding it actually from the house prediction code and changing the values. Now, since you know there are NA values here, I need to remove them. So first what I will do is I will find the data set and I will tell the data set or Python that from this data set and in the columns, check where there are NA values. Find any NA values. When I run this, the code will tell me that the NA values are in the hours. Okay, so the NA value is only present in the hours. Then I will write another code. So now I know that it's in the hours. Then I will say go to dataset hours and fill those hours with those NA values with mean of the rest of the hours column. So what it will do is it will take the entire column and it will take a mean of the ones that are present and it will insert that mean over here. So the program will automatically fill this value. So we're not actually deleting the row. We're not making this row as useless or we are actually using this value for our benefit. The 17.1 and 78.68, we are actually taking all these values, taking an average, taking a mean, and adding to the places where the values are missing. Okay, so that's what we're doing. So we're saying fill these hours with these NA values with mean. So let's say if age had NA values, so it was not hours, it was age. Instead of hours, it's the age column. Okay, so instead here, instead of hours, you will put age then. And here also you will put age. So then that any values that are present in age will the code will actually take an average of all that and fill that blank value that is there in the age column. Agam, is it clear now?
Yes.
Oh.
So the upper index bracket arcs must also be changed?
No, this is output. Here it will tell you which columns have NA values. So let's say if there are NA values in age, then instead of hours, automatically you will have age. Based on this, you will create the code for dataset.age.
Okay.
Clear?
Here in this we had blank values, but in the data set for a predictive model, we have some columns with NA actually specified. With this code, these columns will be dropped or how is it?
Yes. Yes,
Okay.
it will be dropped.
Oh. And
Okay.
if we have to drop the NA values from the text fields, we are changing it to 1, 2, 3s, right? So if we
Yeah, you
have
would have
to,
to change the column first to 1, 2, 3s, and then you would have to put it in the system and then it would change NA values. That's why I'm saying don't take the
Okay.
text columns, take only the number columns. Otherwise, you
Okay.
will waste a lot of time on the text columns. First, you would have to convert it. Then after that, you would have to change the NA values. So it will be more work. Instead of doing
Okay.
that, just work on the numbers.
Okay. Okay.
Okay. Now, here, what we're doing is we're segregating the data. You can use this code, or why do I have print X shape? I will remove this. You can segregate using this code, or you can do this one as well. Actually, so code. Now I need hours, age. If you remember, what are my X's? Hours, age, and internet. So to make this easier, I can do this bracket hours and age, internet. Okay, and then I can run this, and then I can add on that. So I'm not running the other code. Look at that, I'm not running the other code. Okay, uh 1 second. I will make this code down. Then y is equal to data set bracket, and it was marks. And then I need to print this X. Okay, and I need to print this Y. And I will run this. So that's done. My X and Y is segregated. My training data set using linear regression. So I'm doing training now. Look at this, all the codes now look here as well. Your codes are almost the same. You're only changing the words here. See, this code is same. This code is same as well. I will run this and it's running now. Okay. After running this, then I will do prediction. Okay, this is similar. You will see that the prediction is similar. Okay, I have named, oops. I have named A. Now A is the prediction. Now what is in A? I have three things. Hours, so 9.2 is hours, 20 is the age, and 0 is if the person has internet or does not have internet. So for example here, let's say I want to put that this person studied for 10 hours, the age is 15, and 1. And then I run this, it will tell me what marks this person will get. Tell me by now. That's weird. Why this is not running? Okay, so that is the marks that this person will get, 89.346. Okay, let me change this again. Let me make this 4 hours, maybe lesser, 30 minutes. Okay, and let's make this 15 and let's make this a 0. Let's run this and this person will get 52 marks. Okay, let's increase these hours and make this as 13 hours, for example. So more than 100. Okay, so this is the idea for linear regression. Does it make sense? Any questions?
So
Any
the
questions, guys?
regression for multiple variables. So y is equal to mx plus b. How to check for multiple? For each x, do we have a different coefficient, right?
You will have, so y mx plus b would be something like, you will have a different coefficient for each one of them for sure. Okay, so if you want to try, you can try as well. Let's try. I've never tried on this, so I can try. So it's telling me the three coefficients. This is for hours, this is for age, and this is for the
Uh,
internet.
okay.
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 And then I will copy paste the intercept as well. And this will tell me the constant. Constant will be 1. So
Okay.
this is the constant. Okay. So even if, which does not make sense, even if your hours or age or your internet is 0, you will still get 52 marks. This could be because of other reasons. So
Okay.
this could
Okay.
be because of other factors that are getting this person any marks. So maybe cheating. Okay.
Okay. Okay.
So yeah, so that's what it means. This explanation for every line that you have, you need to explain in your predictive model. So now if you look at the instructions, your instructions will make sense. So let me open the predictive model instructions. So this is your coding file. Now one more thing. So I'm saying that I need two things from you for this project. I need your coding file and I need your Word file, right? Now your coding file should be in PDF format. How do you get that? So what you will do is you will go to file. In your file, you will have print. So you will print it, and here it should be saved as PDF. You will save it, and this is the file that you will send it to me, so I can see your code then. So I can see what you did, how many predictions you did. I want to see. So for example, in your what do we call, in your assignment, I have said that I need about 3 predictions. So see, 3 hypothetical values or 3 predictions. So I want to see this code 3 times. Okay, so for example, here this code, I will add a code here. I think the shortcut for this was Control plus, but I don't want to risk it. So I will copy paste this code here and then put another value here, here, and here, and then run it. Then I will copy paste, and then I will have another one. You will show me the result. So let's make this as 3. Okay. What happened? Probably it's because of this. But if it does not run, there is another way to do this. Just make this as it will not run. I know it will not run because what do we say? We have already named A, so the next one should be B. So it will not run. So make sure that you change that value and then it will run. Okay. And if it does not run, then very simple, just put hashtag before this. Once you put hashtag here, this will change into a comment. Now when you run this, it will work, but apparently I have to run everything. So now when you run it, it will work. If it does not work, change this to a comment. Another way, if it does not work, change this A to B. Okay, and then it will work. So I need 3. When you print, I need to see all 3 predictions. Okay, and you need to explain those predictions in your model. So if you look here, I can see this and I can see the next one as well. So I need to see 3 predictions that way. Okay. Um, if you look at, so you will load the data set. I need a code for that. I need a code for summarizing the data set. I need the code for visualizing the data set. I need a code for any values. I need a code, even if you don't have any values, make sure you put the code for any values. Okay. So let's say even if you don't have any value in all your 4 variables, in all your x's, all your and your y as well. Don't worry, I need to see the NA value still. I need to see the code. It's worth 1 mark. If you lose that, you lose this 1 mark. And yeah, you will lose that 1 mark there. Then segregation, training the data set. I told here no training and testing split is required because we're doing linear regression, as you can see. Plus, how many independent variables there should be? It's a multiple variable prediction model. That means I need more than one independent variable for your training. Then 3 hypothetical situations, coefficient intercept, and check if the coefficient and intercept are accurate, the model is accurate or not. Then you explain that. Whatever you found in your code, you will explain everything in your Word document in 500 and 1000 words. You have to include, so when you're explaining the visualizations, make sure this chart that you have, what is happening? I think this is stuck. So this chart that you have, the visualization, you copy paste it, okay, or do copy paste it. So once you click on this, okay, why this is happening? I think this is stuck. The camera button should open, but it's not opening. Anyways, you can take a screenshot of it and you can upload it. But there is a camera button here that works, and then it zooms out and you can actually copy paste this in your sheet. So copy paste this in your sheet and explain the chart. I don't want steps. I don't want explanation for the code. I need explanation about the output. Explain the output. Explain this. Then explain this. Then explain this. Explain the output. Explain this. Explain the output only, not the code. Any questions?
Yes,
Professor,
Sana, yes, I have a question.
Sure.
With the data set that we have, so we can erase the data set that we are not going to use and just work
Yes.
with the, yes, okay.
Professor, I have a
Yes.
question too.
Sure.
The prediction, when we do more than like 3 values,
Mhm.
can you show us like an example with the real data?
With that data or this
I
data?
mean, like the prediction and where they stand on the Excel.
For which one? This one, this data
Like
set, or the other data set?
any prediction, like when you do 3 predictions.
Okay, let me show you with this. Okay. So in this, I had, so this is what the prediction is. Okay. This is the prediction cell. Now in this, I have the first one as x is equal to this. This is my code, right? Now, what I will do is I will stop here. Then I will insert another code cell. Or you can put screenshots of this in your code as well. So for example, if you do not want to create extra code cells, another way of doing this would be take this, take a screenshot of this, save it. Okay, take a screenshot of this, save it in your work document and explain it. Then take a screenshot of the next one, change this number to 50,000. Run this, you will get another value. Take the screenshot of this, insert it in your Word document. Then put 10,000 here and then run this. Take a screenshot of this and then enter it. So you will have 3 predictions that way. 3 predictions means 3x's. Here also, you are going to predict, you're going to have 3x, three times you're changing the x. That's what I mean by 3 predictions. Does that make sense?
Yes, yes, thank you.
No problem.
Professor, I
Any
have a
other
question.
questions? Sure.
Do we have to upload the PDF file with the code and the Word file, right?
Yes,
So,
both in the same link. So I think I have a link here which says prediction model somewhere. Here, individual prediction model, you need to upload your documents in this slot. You will have submit document, Both the documents which should be in this. No point for Turnitin because anyways you're going to do the analysis by yourself. So I'm not doing Turnitin, and it's very annoying. Students they want to upload the document 10 times, and then yeah, they have plagiarism 10 times. So no point of Turnitin.
Oh, okay, thanks.
No problem. So this assignment is due this Sunday on 27th November at 11:59. Please make sure you upload it, okay? All right, guys. Now you can practice whatever I did. Practice. If you have questions, let me know.
Thank
Professor.
you. I think
Okay,
you
thank you,
answered
Professor.
this.
No problem.
Thank you, Sana.
Thank you.
Thank you. Bye bye.
Okay, I have to find, I have to mark people's attendance. So please let me know who are in class right now. And I did not mark your attendance. So I think Hugo is here.
Yes, miss.
And Amarpreet, are you here? Arzu, Sabir, Prabhash. These guys are not here. Okay, guys, you can continue with the Python.
Somebody here.
Done.